grade 10, when you drew multiple lines, you would solve them by elimination, by substitution. Do you remember that? It's been too long? Been too long? Okay. Well, we'll do that using our calculator, so it's a lot easier, a lot more fun, in my opinion. So here we go. I just want to talk about this part here. Like these, I don't know if you tried page 7, if you tried these ones here. Basically, whenever I see a denominator, a fraction of any sort, right, I tend to multiply both sides by it so that, right, this will cancel out on this side and this will just multiply to give you 8 on that side, right? So once you've canceled out that 4 denominator on this side, it's now much easier to work with. So I bring the x's over to one side. This ends up being a vertical line because there's no y variable, right? And same with f. In this case, the 1/3 only affects the y, okay? The 1/3 only affects the y. However, I don't like that. So I'm going to say, hey, I don't like that. So I'm going to multiply. Basically, you're multiplying the entire equation by that denominator. And so that gets rid of the, so you basically go 3 times 1/3, it's just 1, right? They cancel out, so you end up with y. But watch out, right? You need to make sure you also multiply that -4, which gives you -12. And on this side, 3 times 5 is -15. And you bring everything over to one side, you end up with a horizontal line, right? And be comfortable with vertical or horizontal lines. Shouldn't scare you too much. Okay, so I hope you see that. Don't be alarmed. Just, it doesn't happen very often that you'll have to do something like this, but from time to time it does. Okay, I think one of the most common mistakes I see is that students introduce the x variable, right? Don't introduce an x variable if there isn't one. Just let it be, right? All right, let's keep going. We're going to go to page 10 and just review that real quick. We did this already yesterday. Why are we rewriting? Why am I making you rewrite? Because you're going to need to do that in order to use your calculator, all right, to type them in. But I do find the intercepts quite often. You'll see me finding the intercepts by hand quite often. So get used to that, but it's all connected. Yesterday we already found the point of intersection, but I kind of rushed. I rushed to the punchline. So we're going to continue with these two. I want you to type them into your calculators one more time. Okay, and this is a good practice to figure out your window. So I'm going to go type this one into y1, 3x plus 15, and type on the other one, -x minus 20. Again, you just keep practicing these skills and you should see the connection. Okay. Once you type these in, let's flip over to page 11. And this is a bit overkill, the information. You don't need to. You don't need these instructions anymore to find intersection between two lines because we've done a lot of that in quadratics, right? In the quadratics unit. So, but anyways, here, this would be again how you do it. So let's go and determine the POI for the lines created by the equations above. What is POI? It says it right up there. The point of intersection. And there's that word POI right there. So don't let that scare you. POI, here it is again. We're just going to find the point of intersection. Let's do that together. Very important, guys, because if the point of intersection is not on your graph, you're not going to get full marks, okay? It has to be on there. And before I start graphing, I find the POI. So let's graph this, a hit graph. Maybe the window will work for us. Oh, almost. The window I just used almost worked, but I don't quite see it. So I'm going to change my window. I'm going to bring the Y-min down a little bit. Y-min, how about -20? Let's see if that works. Hit graph. Pretty good. Okay. Let's find that point of intersection. Second, trace, intersect, enter, enter, enter. Oops. There, sorry. I forgot to press enter 3 times. And there it is. Let's write it down one more time. -8.75, -11.25. Can I just say something? Look at where it is on the screen. Right? Both should be negative. Sometimes students write down, they miss the sign. It's like they should both be negative, right? So here we go. So I go y1 is equal to 3x plus 15. Y2 is -x plus 20. Oh, minus 20. Get those signs right, guys. I make that mistake too, right? So just make sure you take your time. Then I go second, trace, intersect. And here is the point again. What was it again? -875, -11.25. Okay. So there it is. That's a point of intersection. Now I want you to graph both lines on the same plane. Include labels. Let's figure out the x-intercepts for the first line. So y is equal to 3x plus 15 had, what was my x-intercept? I'm just going to go peek, okay? It was -5, 0, as well as, 0, 15, sorry. I don't need to peek on that one. And the other equation was -x minus 20. My x-intercept was -20, 0, yeah. -20, 0. And my y-intercept was 0, -20. And the POI, which is very important, is -8.75, -11.25. You want to make sure all of these show up on your graph. Okay. So I'm looking at my x values here. I need to go as far as for sure -20 on the left. And when it comes to my y values, I need to go all the way up to 15 down to -20. All right. So I kind of generalize. I'm like, okay, I don't want to, I'm just going to go like this: 5, 10, 15, 20, 25. Like I make a scale that will for sure work for me. And I don't label every single one once it comes down to this point. I'm just going to go like that. And I do the same thing going down: 5, 10, 15, 20, 25. So I'm using a scale of 5 along the y-axis. And I'm going to use the same scale along the x-axis just because it works. I know for sure this is going to work for me. So 5, 10, 15, 20, 25. So this is -10 here, -20 there. Same here: 5, 10, 15, 20, 25. Okay, so let's plot one line at a time. Okay, I always tell my students one at a time. Don't do more than one. So I'm going to go -5, -5, 0 is right there. 0, 15 is right there. And I also tell my students, use your graph to give you a reference. Like, okay, one line goes down like that. Okay, got it. So I'm going to use a red line for that one. It will not look exactly the same as what you have on your screen because your calculator may show a different scale, and that's okay, but it should roughly, approximately look the same. So this is y is equal to 3x plus 15. Please don't just blindly trust your answer. Look at it. Does it make sense? It is a positive slope. It should be going up from left to right. It goes through 15. Okay, I'm pretty sure this is the line. Okay. Next, negative 20, 0 is right here. Negative 20 right here. Big dot. And 0, negative 20, which is way down here. I'm going to use a blue pen for that. Again, it doesn't matter. I just like to make it stand out a bit. Notice how I go way past the points. Like I don't just, some students just connect the points. They go from point to point and just maybe just a little past an arrowhead. Don't do that. Just keep going, right? Because we want to see what these lines look like because they go on indefinitely. If I had Desmos, there wouldn't even be arrowheads, right? Because you could zoom in or zoom out and just keep going. Let's put our equation here. Y is equal to negative x minus 20. It makes sense. My slope is negative, right? It's negative 1. And I'm going through negative 20, so it makes sense. Is the point of intersection approximately where I want it? It says negative 8.75, right? Negative 11.25, so it's approximately where we want it. Okay, so negative 8.75, negative 11.25. That's the only one that I would like you to label there today. That's my point of intersection. The POI is right here. Okay. And that is why I truly believe the intercepts are the best way to do this. Because if you know your intercepts, you have a pretty good idea what your window should be, what your scale should be. Okay. All right. We've only dealt with 2 lines. As soon as you have more than 1 line, we call that a system. Okay. You could have 3, 4, 5. I'm not going past 4. The maximum you ever see is 4. But here's where I'm going to walk you through it. Okay. So this was just a warm up. Some of you are still talking. Make sure you got it. Don't be scared. Yeah. Go ahead. Don't be scared. I'm going to walk you through it, but yeah, you'll need to practice by yourselves as well. So let's go through this very scary looking scenario here. Let me set this up for you. You see 4 equations? Yeah, 4 equations. You're going to have to, at some point, have them all 4 show up on your screen. Right? You're scared, but don't be, because it'll be okay. I want you to, at the end of the day, watch this. They're all going to show up on this grid on page 13. But you're not going to be scared, right? Because we're going to walk you through it. 1 equation at a time. So let's go ahead and do this. I kind of want to, yeah, we'll have time. So I'm going to go and have my key here because I need to know exactly how this goes. So the rearranged equation, by that I mean y is equal to mx plus b. You have to have y isolated to use your calculator. So I hope this is enough space for you. So I'm going to go negative 5y is equal to negative 3x plus 30. So I bring the 3x over to the other side, right? There it is. Then I divide everything by -5. And that gives me y is equal to -3 divided by -5 is positive 3 over 5 x. 30 divided by -5 is -6. Okay. Right now, all I want you to do is rewrite them all. Okay. Bless you. Rewrite this one, rewrite that one, and rewrite y4 as well. I'm going to give you a little bit of time to just do that because it's super important for you to know how to do it. Okay. You see the fourth one? It's scary, right? Y and x, they both have a 3 as a denominator, but you know how to handle that, right? But just try it, a couple minutes. You may not do. I'm taking it back for a bit. So 3y x plus 45 divided by 3. This one, 1.5y is equal to 4.5x plus 18. Divide everything by 1.5. Y is equal to 3x plus 12. In this case, it just works out. If not, leave it as a fraction. As weird as it sounds, like you go 4.5 over 1.2, whatever it is, just leave it like that. That's how you're going to enter it into your calculator. And then the last one, watch, my space is going to be limited here. So I'm just going to go like this, times 3. And I'm going to multiply this by 3 as well. So that gives me 2y plus x is equal to 12, right? Because the 3 multiplies everything inside that bracket. So the thirds cancel out, right? And so that ends up being 2y is equal to -x plus 12 divided by 2 divided by 2. Y is equal to -1/2 x plus 6. I know that's hard to see, but I hope you get it. Okay. For all of these, let's write down the y-intercept because that one is super easy, right? 0, -6, 0, 15, 0, 12, and 0, 6. Okay. You just grab the y, the constant at the end, boom, done. The x-intercepts, I want you to do that as well, okay, using the calculator. So grab your calculator. We're going to type in all of these into y1, y2, y3, and y4. Are you ready for that? Well, here we go, guys. Type them in. So watch how I do it. 3/5. I'm going to go bracket 3 divided by 5, close bracket. X minus 6. Next. Bracket -17 divided by 3, close bracket x. You're faster than me. What am I doing here, right? You're already done by now. 3x plus 12, -1/2. I do believe that taking a little bit of extra time saves you in the long run, right? So don't be texting, you're texting fingers, put them on hold, right? I know we can't beat that, but make sure you take a moment and make sure everything is right. Okay, now, this is a little overwhelming. Let's graph it. Just for kicks, just for fun and games. Boom, 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 boom. Hey, that actually works out pretty good. Okay, that actually works out pretty good. Is everybody seeing all lines? You're seeing lines, right? All right, good. Is it smart to have them all on at the same time? I don't know about that. So what I'm going to do here is I'm going to go y equals. I'm going to turn off y2, y3, and y4. y5, I'm going to make that equal to 0. Boom. So make sure it's on. Make sure you go 0. So the only two that are on is y1 and y5 right now. Hit graph. Perfect. See that green line? I don't know what it is for you. It might be a different one, but there is a line graphed along the x-axis. Let's find the x-intercept. Second, trace 5. Enter, enter, enter. It's 10, 0. Okay, so we'll write that down. 10, 0. We go back to y equals. I turn off y1, turn on y2, repeat the process. Hit graph. Boom and boom. Second trace 5. Enter, enter, enter. This one is different, right? This one is 2.65 rounded 0. And you know the drill now, right? I turn off y2, turn on y3, hit graph again. Second trace 5, enter, enter, enter. -4, 0. And one last time. Turn off y3, you hit enter on the equal sign, right? Hit enter on the y4, hit graph. Second trace 5, enter, enter, enter. That's 12, 0. I kept them reasonable, okay? Like, none of these numbers are out of, right? We're not even going past 20, right? Okay, I want you to ignore this for now. We're not going to worry about this. I just want you to be able to graph this, right? So we're just going to focus on the equation, the intercepts. So now we're going to play this game here. Watch this. Question 2, 3, 4. I want you to determine the intersection of lines y1 and y2. So which two lines are you going to have on? You guessed it, y1 and y2. I'm going to turn off, like the y5, turn that off, right? And y4 as well. Just the first two. I could do all of them at the same time, and I'll show you how to do that. But for now, we're just going to keep it like this. Graph. The intersection shows up. No need to change the window. Second trace 5 there. Enter, enter, enter. I don't want you to put in the keystrokes here. I will say that this is a bit of an extreme example that you're not going to really have 4 complex lines at the same time, but you will have multiple lines. Some of them are going to be a lot easier. So let's keep doing this. So y1 and y3. So we're going to turn off y2, turn on y3 because we want the intersection between those two lines. Hit graph. And there it is. Second trace 5, enter, enter, enter. That's -7.5, -10.5. And so forth. Try to find the other ones. I'm just going to give you the answers. Find a couple more just to make sure you know how to do this. This is all just kind of like exercising for what we're doing next, right? So you're up for the task. So find a couple more, see if they match. Once you've found 2 or 3 and you're like, you know what, I get it, it's working for me, you're good. Okay. And then we're going to graph them. Scan your points real quick here. If you can tell, look at the y values. If I'm within a window of like 20 up and 20 down, as well as the x, I'm gonna be just fine, right? And scan your intercepts. If I'm in the y, if I go up 20, down 20, same with the x values, I'll be just fine. So that's what you want, just ballpark. Just make sure you have a window that will fit everything in. I just had an idea actually. If you go to your window on your screen, if you were to go by those numbers, you'll be fine, right? Oh, I need to go negative 2020 and negative 2050, right? Even though the 50 is probably overkill, but that would definitely work as well. Let's go and graph this. And I know, I wish I would have set it up in such a way that the graph is right next to this, like the points we just found. So I'm going to help you out. The very first line is 10, 0, 0, negative 6. Hey, I gave you numbers, so we don't even need to worry about the scale. I forgot about that. So x and y, don't forget that. Arrowheads on all axes. And let's go. 10, 0 is right here. 0, negative 6 is right here. We're going to sketch that and then label it right away. Okay, I don't have enough colors to give them all different colors, so we're just going to... And you know what, my ruler... I'm going to grab a longer ruler here, a little longer, just make sure I go way past, because it could be that it's crossing down here as well. Okay, so I'm going to just make sure. Unless it's a word problem, it's okay to go way past the grid. Next, this is the equation y is equal to 3 over 5 x minus 6. That's this one here that I just plotted. The next one is 2.65. This is 2.5. 2.65 is just slightly over. 2.65, 0.15. So 0.15 is way up here. Has a negative slope. It makes sense that it's dropping. And then you just go and graph it. Right, and this is y is equal to negative 17 over 3x plus 15. Label it right away so you don't have to worry about it. The next one is negative 4, 0, negative 4, 0, 0, 12. It has a positive slope, makes sense that it's pointing up. And now you start seeing that it's going to cross a number of lines, and I want to make sure they cross. Boom, boom. I label it always at the end normally, at the tip of the... So y is equal to 3x. And please, as you write down your equation, it's like, does it make sense? I have a positive slope, it's pointing up, it's going through 12, right? It does make sense. And then the last one is 12, 0. So 12, 0 is way over here. And then it's 0, 6. So you go to your y-axis, you go all the way up to 6. Whoa, right? I don't think you did this in grade 10. I don't think you did. You graphed 4 lines. You may have done 2. There's that one. And I'm going to label it right away. And I use the rewritten form. This is negative 1/2 x plus 6. Does it make sense? Yep, it's pointing down and it goes through 6. Okay. I'm going to use a highlighter because we still have time. I'm just going to circle all the points of intersection between the lines. Points of intersections are points between lines, not axes. Axes we don't care. Those are called intercepts, right? So maybe just trust me on this one, because if you had to flip back and forth, this would be pretty painful, right? This is negative 7.5, negative 10.5, this one right here. This one is 3.35, negative 3.99. This one over here is 10.91, sorry. 10.91, 0.55. This one over here is 1.74, 5.13. So we've got 2 more left here. This one is negative 1.71, 6.86. And this one way at the top here is 0.35, 13.04. Okay. I want to try one more thing before we go. Nothing, you don't have to write down a thing for this one. You just have to follow what I do here. Grab your calculators and turn them all on, all Y's. Y1 all the way to Y4. Turn off, keep Y5 off. We don't want that one. Just all 4 at the same time. You got it? You ready for the challenge? If I asked you, hey, I want to find this one right here, this point of intersection, which is right there. You could actually do that with all of them turned on. Watch. You go second, trace, intersect, just like before. But now you have to be careful. So you are on the blue line, which is definitely one of the lines you're interested in, correct? Let's go a little closer to it. Hit enter. Boom. Which line are you on now? It jumped to this line, right? That's definitely not the one we want. Which one? Which other line do we want? We want this one here, right? So you go arrows up or down to jump to this line. And it even tells you at the top which line you're on, right? So I'm going to go arrow up, jumps to blue. Arrow up, jumps to purple. Arrow up one more time. Now I'm on the line that I'm interested in. So you're telling the calculator, I'm interested where these 2 lines meet. So that's when you hit enter and then enter one more time. So you can't just hit enter 3 times blindly. You have to tell it which 2 lines it is. And watch, it matches, right? Negative 7.5, negative 10.5. Try one more. Let's try to find this one here. No, this one. This one right here. Let's try to find that one, which would be, for me, here. This one right here. So second, trace 5. I'm going to jump until I get to either the purple. Now I'm on the purple. That's good. Hit enter. And I'm going to jump till I get to the red one. What's happening? Houston, we have a problem. Oh, there. Now I'm on the red one. Enter, enter, enter. Boom. It's 1.74513, right? Which is this one. Homework. You thought I was never going to say that, right? Page 14 and 15. You do basically the same thing again. Okay? I will post the key. It'll be exactly the way this looks, just all filled in. I would say don't worry so much about these two columns here. Just rearrange, find the intercepts, and then try to graph it. Okay, guys? Thank you. And tomorrow we're going to start inequalities. We haven't talked inequalities yet.